Hi folks, let's machine this microorganism piece. The folks over at Tools Today that we've done some videos for before wanted to know if we could machine it. It was an STL file that has 600,000 faces or facets to it, and it's definitely something I don't normally do, both the file type but also just the general machining strategy and the outcome, the part. We actually sort of did it the wrong way. I want to talk about that today. And the piece we're holding, it turned out great, but we relied too much on the 3D adaptive strategies. And I'm going to talk through some of the things we learned, the CAM strategies, how we set this part up, how you can make it, and then at the end we'll let some machining footage run. We got some time lapse as well. So we relied too much on 3D adaptive strategies. I really fell in love with this strategy when I started using HSM Works and now Fusion 360 because it does such a good job of maintaining constant chip load, which is really helpful and a very powerful toolpath strategy. It can prevent you from breaking tools, it can give you a better surface finish, it can really help you dial in your machine, whether it's a really small benchtop machine or a huge factory machine. The problem is it's an incredibly computing powerful, or takes a lot of computing power to do it, and I learned why. When I was talking to some of the folks at Autodesk University, and I may botch some of the exact specifics or lingo here, but basically it creates a solid model in the background for every pass or every so often, and then it does like a comparison, like a before and an after. So it creates a little bit of toolpath, erodes that away, creates a solid model, does more, and then it compares how much was removed versus how much it thought it removed. So it's sort of like iterative, and it's like a brute force method, which is really cool. And you know, computers nowadays can do a lot of that stuff really quickly. But the model here, I was doing a 3D adaptive toolpath with a 1 millimeter, that's about 40 thousandths ball end mill for the final pass, and I had to let my computer do the CAM rendering overnight. It was like 12 hours. And hey, if you need to do that, that's okay. There's nothing necessarily wrong with that, but you're gonna see here, you can generate a morphed spiral toolpath in literally seconds, and that's what's also really cool. So how do we make this part? We got a chunk of 360 brass free machining, should be really nice. We're definitely using the 440 because we've got the 10,000 RPM spindle. We're gonna start off with a it's funny, I actually had left the 2D adaptive as a separate job because I was so scared of causing my CAM toolpath to have to require an update, and it would take overnight to do so. But now, no big deal. I can just drag this up here and regenerate everything. To start out, we'll use tool number 51402 from Tools Today. It's a single flute 1/4 inch end mill. We'll use that to just rough out the stock around the piece of brass we've got. And then we'll use RC 3400, it's a 4 flute, about 2.5 inch face mill. It'll give us a really nice finish over the top of the part. And then we're going to come in 3/16 inch ball end mill, and here you can see we can really hog out a lot of material. Now I'm doing adaptive roughings here, and I like to do them in 2 different passes. It's the same operation. In the first pass I'm going a little slower, 20 inches a minute, but I'm taking a little bit more of a step over here, about 75 thou, and a more generous depth of cut. I kind of want to use it as a roughing, hogging out operation. And then I'm duplicating that same tool. We're going a little faster, and we're taking a much finer step over. We're still leaving 2 thou radial and axial because remember, the adaptive roughing strategies aren't finishing strategies, and sometimes they can actually, I don't want to say cut corners, but they're not meant to hug the exact perfect end contour. So you do want to do a finishing type pass. We're switching here to a tapered 1/16 inch carbide end mill. We'll use that to come in, and again, we're just trying to remove that material out as we get to progressively smaller bits. Now here's a really good question is, I like the adaptive roughing strategy because I feel like it helps me ensure I'm not going to plunge that tool into a bunch of uncut material and potentially chip load it or break it or just impact a negative surface finish because again we had some deflection because we pushed it in too far. So that's the attractive thing. This one though is taking a few minutes to calculate. So I'm okay with that, but it's starting to get that point where it's inefficient. 10,000 RPMs, 21 inches a minute, and we're going to do 30 thou step over and just and up to no more than 0.1 inch step down if it can, but the fine step down will be 0.01 inches here. And you can see pretty cool toolpath when you look at it, and you can now see all those little triangles around the part, right? We'll come back and look at a simulation here in a second, and here you can see the 0.01 inch step downs that I was referring to. So it'll go down as far as 0.1 inch. I'll pull this back up here if it can, but if it starts to see taper, it'll say, okay, well, the operator doesn't want me to go more than 0.01, so that I can make those stair steps as small as again I want to here at 0.01 inches. But it's obviously not going to create stair steps or go down 0.01 if it's a straight wall up and down. And then finally, we'll do a morphed spiral. I love this toolpath. Now, how did I pick morphed spiral? Well, I wish I had done this whole thing in Fusion 360. Apparently, Fusion 360 can't quite handle the STL file yet, but it definitely can handle the CAM side, so I'm hoping that they'll get the STL side sort of up. But I actually used Fusion 360 because they have the great hover over pop-ups, and if you just go down through the various CAM operations, you'll see morphed spiral. This strategy generally provides a much smoother toolpath than scalp and is very useful when machining freeform or organic surfaces. I can't think of a better example of an organic surface. This literally, somehow, the folks at Tools Today had this made from a microorganism, like some biological thing. It kind of looks to me like a moon craters. It's kind of a cool part though. And so more spiral it is. We're going to do the first one with that same 1/16 inch end mill, and God, it's just beautiful the way it hugs it and goes over that, and it generates very quickly. And then the last strategy we'll do is the same morphed spiral, but with this 1 millimeter or about 40 thousandths ball end mill from Tools Today, part number 46471. All this info is in the video description below. And holy cow, folks, look at this toolpath. Isn't this beautiful? And what's cool is we can use stock simulation as a really helpful tool, but let's look at just the regular simulation, and we can see, hopefully it'll work okay here with the graphics card. So I'll slow it down, and let's change the toolpath to just show a tail. And if you slow it down a little more, you can really see, we zoom in, I mean, it's crazy. You can just watch it going over, and you can see just how fine a detail this part is. We take a look at our stock simulation. Again, it's a bummer that the screen recording software really makes it difficult to run smooth simulations. I think it's just really taxing on the graphics card. I suppose I could use a camcorder and film my screen, but the screen capture software seems much more elegant, except for this area. What I wanted to emphasize though is you see the colors here, and they correspond to the operation. So you can actually watch the part be formed, and you can see what operation took material away, and you can see at the end, you know, for instance, the cleanup end mill didn't have to go where the bigger end mills earlier could cut everything sufficiently. So here you're starting to see the purple. I wish you could see more easily. It'll describe it here on the left, I guess. Yeah, you can see the morph spiral. So here's the second to last operation. This is the 1/16 end mill in that sort of ugly, you know, pea soup color. And then the last one will be a green color, which is the morph on the 1 millimeter ball mill. And so you can see here, it doesn't have to cut everywhere. It just has to cut where, or it's not cutting additional material away, I guess you should say, because again, some of the bigger areas the whole tool could get to. So with that, folks, I hope you learned something. So sit back, relax, enjoy some footage of cutting this brass part here on the Tormach 440.